Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, show that the graph of f at x equals ax to the power 4 plus bx to the power 3 has 2 points of inflection. And then show that the x-coordinate of one of these points lies midway between the x-intercepts. So let's start with the first part. Show that the graph of f at x equals ax to the power 4 plus bx to the power 3 has 2 points of inflection. So points of inflection are points at which the second derivative of the function is equal to 0. So we'll have to find the second derivative of this given function. So we'll start with the first derivative. So we get prime of f at x equals, so for the first derivative, so in the first term, the a is the coefficient of the term, so it will stay as it is. And for x exponent 4, we can use the power rule to find the derivative. So as per the power rule, we'll move the 4 to the front and we'll subtract 1 from 4. And then plus, so in the second term, b is the coefficient, so it will stay as it is. And we can use power rule for x cube, so we can move the exponent 3 to the front and subtract 1 from 3. Now we can simplify this expression. So a times 4 is 4a, then exponent of x is 3, and the second term b times 3 is 3b, and the exponent of x is 2. So this is the first derivative of the given function. Now we can find the derivative of this derivative to get the second derivative. So in the first term, 4a is the coefficient, so it will stay as it is. And for x cube, we can use the power rule to find the derivative. So we can move the exponent 3 to the front and subtract 1 from 3. Then plus, in the second term, the 3b is the coefficient, so it will stay as it is. And for x squared, we can use the power rule, so we can move the exponent 2 to the front and subtract 1 from 2. Now we can simplify this expression. So 4a times 3 is 12a, and then in the exponent 3 minus 1 is 2, and in the second part 3b times 2 is 6b, and just x. Now to find the inflection point, we'll sub in the second derivative as 0 and solve for x. So we have to solve this equation. So the first thing we can do is to do common factoring. So we can factor out 6x from both terms. So now we get two cases. So the first case is 6x equals 0. And now we can divide both sides by 6 to isolate x. So the 6's on the left side get cancelled out. So we get x equals 0. So this is the first inflection point for this function. Now we can analyze the second case. So now we can subtract b from both sides because we have to isolate x in this equation. So the b's on the left side get cancelled out. Now we can divide both sides by 2a. So 2a's on the left side get cancelled out. So we get x equals negative b over 2a. So this is the second inflection point for this given function. So we have proved that the function has two inflection points. Now we can answer the second part. Show that the x-coordinate of one of these points lies midway between the x-intercepts. So first we have to find the x-intercepts of the given function f at x. Now to find the x-intercepts, we should sub in the function value as 0 and solve for x. Now we can do common factoring because we have to solve this equation. So we can factor out x cubed. So now we get two cases. And now we can isolate x in this equation by applying cube root to both sides. So on the left side, the cube root and the cube get cancelled out. So we get x equals 0. So this is the first x-intercept of the given function. Now we can analyze the second case. So we have to solve for x. So we should subtract b from both sides. So the b's on the left side get cancelled out. So we get ax equals negative b. Now we can divide both sides by a. So the a's on the left side get cancelled out. And we get x equals negative b over a. So this is the second x-intercept for this function. Now we have to show that one of the inflection points lies midway between the x-intercepts. So the next step is to find the midway of the x-intercepts we just found. And for that, we should add these two x-intercepts and divide the result by 2. So we do 0 plus negative b over a over 2. Now we can simplify this expression. So in the numerator, 0 plus negative b over a will just be negative b over a over 2. Now we can simplify this expression by changing it into a division statement. And now we can change it into a multiplication statement by flipping 2 into 1 over 2. And now we can multiply these fractions. So we multiply the top terms and we multiply the bottom terms. So we get negative b over 2a, which is one of the inflection points we got. So that means that one of the inflection points does lie midway between the x-intercepts of this function. Now we can find the y-coordinates of these x-coordinates of the point of inflection to find the points of inflection. So we'll sub in these x values for the points of inflection in the given function. So let's start with f at 0. So we sub in x as 0 in the given function. So 0 exponent 4 is 0 and a times 0 is 0, and same with the b term, so both terms become equal to 0. So the value of the function at x equals 0 is 0. So the first inflection point is 0, comma 0. Now we can sub in x as minus b over 2a in the given function. Plus, now we can simplify this expression. Now negative b over 2a to the power 4 will be equal to b to the power 4 over 2 to the power 4, which is equal to 16, and then a to the power 4. Now in the second part, so negative b over 2a to the power 3 will be equal to negative b cube over 8a cube. Now we can simplify this expression further. So in the first part, the a in the numerator and one of the a's in the denominator can be cancelled out. So we are left with b4 over 16 a cube. And now in the second part, b times negative b cube over 8a cube will be equal to negative b exponent 4 over 8a cube. Now we have to combine these fractions. So we'll have to find a common denominator. So for the common denominator, which will be 16a cube, we'll have to multiply the second fraction by 2 in the numerator and the denominator. So we can continue here. So f at cube minus now we can subtract these fractions. So we get so this is the y coordinate of the second inflection point. So the second inflection point can be written as so this should be the final answer for this problem. So this is the second inflection point for this function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to homework help. Thank you very much and have a nice day. Bye.